The first test. This section is designed to help you find the next test to select from the video menu. Go through this carefully. Try to find a spot that identifies a failure that you can go use for further testing.
Connect your scan tool and select engine data. Start the engine and then make sure that it warms up to operating temperature. Make sure the system closes loop. If the system doesn't close loop, check the oxygen sensor operation and the ECT. The oxygen sensors must be working normally before testing the fuel system. So snap the throttle and watch the oxygen sensors. They should go to at least 0.9 volts, 9/10 of a volt, as in our example here where the sensors are working normally. These sensors are not working normally. When we snap the throttle, one went to 0.6, the other went to 0.4. They are not working normally. If the sensors don't respond normally, add propane to the engine to see if you can get them to measure a rich condition. If the sensors respond normally, when you do propane enrichment, go to fuel pressure volume testing and find out why you're not getting enough fuel on the snap. If the sensors do not respond normally with the propane, replace the oxygen sensor that does not respond. In this case, we're showing you one sensor has to be replaced. Fuel trim data is only valid when the oxygen sensors are working normally. That's why we had you do them first. Look at long-term fuel trim. Ideally, it should be under plus or minus 5%. In our example, they're under 5%. On vehicles with high mileage or not maintained that well, you're going to have to put a fudge factor in there. So long-term fuel trim should not exceed 10% in those cases. You can see that they're under 10%, our example here, but they're over the ideal 5%. Then look at short-term fuel trim. Ideally, once again, it should be under plus or minus 5% like our example. On vehicles with high mileage, put the fudge factor back in and use under plus or minus 10%. Add long-term fuel trim and short-term fuel trim together. Just add them up, all of them. In our example here, we come to 6.4%. Together, they must be less than 10%. And then, to get total fuel trim, add the rear oxygen sensor voltage or percentage in, and in this case we have 9.2. Altogether, they should be less than 10%, and our 9.2 shows that. If together they are less than 10% and the oxygen sensors are good, the vehicle doesn't have a fuel control problem. When long-term is higher than 10%, it indicates that the engine's running too lean. Too lean is caused by not enough fuel or too much air, a vacuum leak. When there is a minus sign in front of the long-term fuel trim or short-term fuel trim, it indicates that the engine's running too rich. The minus is subtracting. Too rich is caused by too much fuel or not enough air. Use total fuel control by adding all the fuel trims together. If you're working on high mileage or poorly maintained vehicles, allow a higher than 10% total fuel trim value. You're going to have to use your experience, and your gut tells you how much higher. In this example, long-term fuel trim is too low. Now look at these examples. We're going to give you some vehicles that we've seen. You can see that long-term fuel trim is under the minus 5. The PCM is subtracting fuel, the minus sign, because of a rich condition. Long-term fuel trim is too high in the second example. The PCM's adding fuel because of a lean condition. You need to compare long-term fuel trim with the oxygen sensors. Normal oxygen sensor voltage, like we said, is continuously moving between 0.1 and 9/10 of a volt, just like this example here. The oxygen sensors are moving between 0.1 and 0.9 in this example, indicating to us that the oxygen sensors are good. In this example, we have a commanded rich condition. The long-term fuel trim is higher than normal, and we have a lean operation condition. You can see that the oxygen sensors, both of them, are lower than normal. If long-term percentage is higher than normal and the oxygen sensor voltage always remains low, it doesn't cross, it always remains lean, go to vacuum leak test. Now in this case, you would be looking for a vacuum leak that would affect both banks because both sensors are too lean. If no vacuum leak is present, go to fuel pressure, fuel volume testing, and find out why you're not getting enough fuel. In this example, long-term percentage is higher than normal and oxygen sensor voltage is always high. It always remains high, rich. The data is telling us that an input into the computer is reporting a need for additional fuel, and the PCM saying, hey, I'm going to send it. The additional fuel isn't needed, and that makes that an invalid command. Go to scan data testing and find out which data bit is incorrect. Here's a different example. If the oxygen sensors are switching normally and long-term fuel trim is higher than normal, the data indicates that this is a valid command. What we're saying here is just because long-term or short-term is higher or lower than normal, that doesn't mean that the oxygen sensor should stay rich or lean. What we're seeing here is long-term fuel trim shifting enough to make the oxygen sensors cross normally. This is a valid command because the oxygen sensors are switching normally. This is a typical lean condition, and it's caused by vacuum leaks, low fuel pressure, or volume, dirty injectors. It could be a mass airflow that was dirty and measurement is too low. It could be low engine vacuum, or a combination of any of the above. In a different example, the oxygen sensors are crossing normally, and long-term is lower than normal. And the data indicates that this is a valid command. In this case, the computer shifted low to make the oxygen sensors cross normally. This is a valid command because the oxygen sensors are switching. This is typical of a rich condition caused by high fuel pressure, injectors that are dirty and leaking, mass airflow measurement that is too high, coolant temperature sensor measurement that is too low, EGR position signal too high on a road test, during a road test, or a combination of any of the above. Use long-term fuel trim and the oxygen sensor information to get a direction in where to take your diagnostics, in what to test next in the fuel system. Vacuum leaks and dirty air filters are the most frequently missed problems found on all the vehicles that have been referred to us.
This is the end of this test sequence. You should make a selection from the test menu based on your test results, or repeat the last test again to help identify the best test